Alright, welcome everyone to my second weekly What's New in C++ live stream. So today we're going to be trying to implement generators using C++20 coroutines from scratch. We'll see how it goes. I don't know if I'll get the whole thing done, or if it will work, or if it will all crash and burn horribly, but we'll give it a try. So, if you don't know what generators are, maybe I can quickly go through. If you've ever used Python generators, it's the same kind of thing. Like if we go to the Python documentation, we can find some examples here. So like in Python, if you want to say get the first n integers, sure you could build up a list in memory and return that, and you could do the same thing in C++. You could build up a std vector of those numbers if you wanted. But you know that's not very efficient because maybe we don't actually need that many. We have to hold that whole thing in memory, which is not great. So we don't really want to do that. So in Python, you could like write an iterator type, which has a lot of boilerplate, and you could do the same in C++ with even more boilerplate. Like you could write your own first n iterator. Hey Mayflower, hey Claim. You could write your own like first n iterator type or first n range, and it would be quite a lot of code and be quite frustrating. Python lets you do generators, so you just write like straight line code, and this yield keyword does all the magic. So this function stays around for the whole time, and it suspends. So when you call yield, it's not like this function stops and returns a value and all of the local variables are cleaned up and stuff. It actually suspends the function or coroutine back to the caller, and then it can get resumed later. So you could like lazily generate all of these values. It's the same kind of thing as an iterator, but you don't have to write all the boilerplate. You just write straight line code, and you can suspend the coroutine back to the caller and then resume it later to get more values. It's really cool. I really, really like this feature. And so C++20 comes with coroutines in that, let's have a look at the CPP reference page. It comes with coroutines in that it comes with support for coroutines. What it does not give you is the necessary types to actually use them in your code. So like the feature in C++ for coroutines is super general. You can do so much with it. Like it just says a coroutine is a function that can suspend execution to be resumed later. That's what C++ gives you. It gives you underlying functionality to then implement more complex uses on top. So some examples that it gives here are tasks, which are like asynchronous tasks. That you might want to read something from a buffer, but that might take some time. So you want to like queue up this and then go do something else, and then later this function will get resumed. This coroutine will get resumed, and you'll do more once this read is actually completed. This is what we want, a generator type. Hey, thanks to follow John Christ. We want a generator type. This is an implementation of iota, which is the worst named function. Well, one of the worst named functions in C++. It's essentially just like subsequent integers in this case, yielding like 0, 1, 2, 3, 4, 5, 6, 7, so on. And you can supply the initial result. And so this is the same kind of thing as the Python generator, right? Instead of yield, we have co-yield. But other than that, it's the same. This function's going to keep sticking around all of the state. When we call co-yield, it's going to return back to the caller, and then we can resume it later. And you can also do lazy values, things like that. You can do anything with this. You can even implement like monads for std optional and things like that. Hey, thanks JBuzz. Alright, so let's get started. I'll create a new project. Gonna make it a CMake project, and we'll call it generator. Alright. Good start, good start. So I'm gonna, as I said, like start from scratch. I might steal some CMake from one of my own repositories because I hate writing CMake. No one likes writing CMake. So I'm gonna go ahead and I'm gonna stick this on Git as well. The fonts are a little bit weird because I made them bigger so that it works nicely. All right, we're gonna call this generator, and put it here. So I'll be pushing this to GitHub as we go. I might forget to commit and push, but people can remind me, and I'll definitely push the end result. So create and push. This will go and actually, just from Visual Studio, it will go and create a repository in GitHub for me. I'm planning 2 hours. I don't know how long it will take me to get stuff implemented. It might be shorter, it might be longer. All right, so this is created. It does create master by default. I don't like that. I think we're planning on changing that. In fact, you know what? I'm gonna go change that in GitHub right now. So hopefully this will have created a generator repo, yay, with the default CMake stuff, which is kind of cool. And then I can just go ahead and change the default branch here. Yay. All right. This is just updating. Come on. It's because I'm trying to like run the stream and do Visual Studio all from my, oh no, don't do this to me. All from my Surface laptop, which was fine last time, but. Hey, Grillers. I will be so upset if this just decides to crash on me from the very first. Yeah, okay, I'm gonna restart you. This is what I get. No, don't report to Microsoft. Yeah, the source control does usually work fine in Visual Studio. I don't know why it's deciding not to work for me. But anyway, while that's reloading, I can go over what we need to do for coroutines. Now, you haven't really missed much. I've just been getting set up. So we have a promise object, which is manipulated from inside the coroutine. So that's going to be essentially the channel through which we communicate our results back. So that's going to hold like these values that we yield. Go ahead and restart Visual Studio. We have the coroutine handle, which is essentially a representation of a handle to the coroutine, which is the function which can be resumed. We have the coroutine state, which is something that we don't really see. It's handled internally by the compiler. So that's basically like a frame, or sometimes called an activation record, which saves things like the promise object and parameters and any local variables, temporaries, things like that. It does say that this is heap allocated. The idea is usually this thing can be stored on the stack instead, so we don't need to do heap allocation, or at least in a lot of different cases. So that's handy. Hey, thanks for the subscription, Dominic. So we have promise object, coroutine handle, coroutine state. We're going to have a few other things because I want this to be usable with ranges. Like I want to be able to take my iota and like pipe it into like a take view or something like that. Thanks for the follow, Helios. So hopefully this is loading. I don't know what it's doing. I was playing around with other stuff right this morning, so I don't know what this is up to. That's loading. All right, so yeah, I want to be able to pipe this into std ranges, which means I need to do a bunch of other stuff like implement iterators and implement ranges on top of my generator in order to get this all to work. Okay, this looks like it's doing a bit better now. Right. This is going to be header only, so I'm just going to go ahead and delete that. Yeah, go away. I want to have some tests, so I'll go ahead and I'll create a tests folder. not in there, in here. And for now, I'll just have test.cpp. I think I'll use catch2 for doing the tests. Hopefully that will work okay. And you know what, I can use VC package for this. So one cool thing in VC package now is it has manifest files, so we can just make a JSON in here, and I know there's a schema for this somewhere. Where is it? So I can like declare catch2 as a dependency. VC package schema. Are you gonna give this to me? This looks legit. Just copy pasting stuff from my Google window. .json. Is that a thing? Is that a valid schema? It's not an official format for the schema, but it's, you know, it's supported by Visual Studio, and it makes writing these things a lot easier. Okay, that wasn't quite right. I'm just gonna go searching for it. Schema. There we go. This should, this is a pretty new feature, so at some point this will be one of the pre-populated options. But now, hopefully I get, yay, there we go. So package name is going to be generator, version, say 0.1 for now. Dependencies, catch2. And then I could put any other information here I wanted, like maintainers, that's me. And then we could push this to VC package when we're done. Just a nice thing we could do. Is that everything? Description. Let's give it description so that we know what we're doing with. So this is a C++20 generator implementation on coroutines. Cool. So we've got our VC package JSON, and let's see what happens if we cannot determine linker language for target. That because I deleted my thing here. All right, let's go ahead, delete this CMake list. We don't need that. We don't need subdirectory. We can have add library called generator, which is a interface because it's a header-only library. Interface is the way of doing that in CMake. Oops, not that. We're going to add an executable called generator test, which is going to be test/test.cpp, and then we're going to link against, well, not link against, but we're going to use catch2. So I'll say find package catch2. It's actually one of the pre-populated options because it's in VC package. Required. And generator test will depend on generator and catch2. Cool. Let's see what this does. Error, could not find catch2. Why not? Why not? I missed the header in the library. Yeah, I guess I need target. How do you do this in CMake again? I want, because if you write something here, then other things complain. So you have to say like target directories or something. Can I compare implementing cooperative multitasking with NT fibers versus coroutines? I can maybe do that later once I've got stuff working. Okay, this looks like it's doing something now. Running VC package install. So this is hopefully going to go and find... yeah, like I could do target include directories here, just because it's easier, but... generator. There, that's what I want, isn't it? I can't remember. I hate CMake. I know like exactly enough CMake that I can convince other people to write CMake for me, which I'm very pleased about. Yeah, no, I'll definitely get to that later. We are working a lot on debug support for coroutines right now. There will be more stuff coming in the next 10 preview 2, I think, is going to come with a lot more debugging features for coroutines. There's already stuff in there, but it'll just have a bit more. Okay, this is compiling now. That's good. So let's say what we're going to try and achieve. We want generator, we want... Oops. Catch 2. Give me it. Is it still loading? Anyway, we want something like the... You know, let's translate this Python into our C++. So, get rid of these. So we want a function, let's say, test case, first n. Yeah, I'm going to delete all this, don't worry. So we'll make this a template, and it's going to be using our TL generator for that T. So this is how you do coroutines in C++. You do it all but with the magic of your return type. So we're going to call it first n. We're going to take some T. Will do. And then we'll start with I'll name it the same, equals 0. And then while num is less than t, we're going to co-yield num and increment num. Yep, good idea. Could multi-string literal. I guess this is fine now. I can delete this. Okay. So I think this is right. This is what we want. We start off with 0. We're just gonna keep on incrementing num and yielding it back to the caller. And then in our test case, it's gonna be something like this. We could say auto gen equals first n 3, and we can drive our coroutine manually for our first test, and then we can get more do some more interesting thing with ranges later. So it would look something like this. We get our generator, and then to drive the generator we need our iterator, which we get from gen.begin, and then we can require that dereferencing the iterator is 0. We can increment it. We can require that it's 1 and then 2. So this is the kind of thing that we're hoping will work. We're just going to generate the first 3 numbers starting from 0, and all the magic will happen. Right, are you going to give me catch tuner? So this doesn't consume the value. Because the coroutine frame is going to stick around for the whole time, we're not going to have lifetime issues with just taking pointers and handing back references. So doing a dereference is just going to give us a reference into the coroutine frame, essentially. It's not going to be consuming anything. Like, you could implement it by consuming, but I'm going to do it differently. Am I going to get catch tuner? No, why not? And why is this complaining? Oops. What did I need to do here? Said that my target link libraries. Oh, does it need to be the root? So is this just generator? All right, nice. Why am I still not getting catch? So it's going to at least give me generator.h, and then, there we go, okay. I can work out the catch issue later. But anyway, we're going to need to do some stuff in here, so let's just remove all of this. All right, so now we can start implementing our coroutine. Thanks to follow them. Namespace TL. So our main template, thanks to follow Rick, is going to be generator. And now we're going to go through our this thing here and work out what we need. So we need a promise object, and I'm going to just go ahead and make that template in a detail namespace. If I was using modules, like, I could technically use modules here, but because I'm using CMake, it's a little bit of a hassle. If I was using modules, I wouldn't have to use detail namespaces. That's one of my favorite things about modules. God, they're really frustrating. Okay, so I'm gonna have just make this a struct. I don't care about doing this properly, really. Generator promise. So this is going to be the communication channel for between our generator coroutine and our code. So this is going to enable us to get values out of the coroutine, which is cool. Okay, so what do I need in a promise object? So I'll just kind of go through this top to bottom, I guess. When coroutine begins execution, the coroutine state object is allocated. Now, we're just going to let the compiler handle that. You could like supply your own allocator here, I guess. We're not going to do that. We'll just not bother. The compiler's then going to copy all of the stuff into the coroutine state and call the constructor of the promise object. Okay, so we need a constructor for generator promise. I'll just explicitly call it out and default it. Okay, then we need get return object. Okay, so this is going to be returned back to the caller when the coroutine first suspends. So this is going to return our generator type. So our promise is going to create an instance of our return object. So we're going to return a generator t, get return object. Generator's incomplete right now, so I'm gonna leave the implementation of this until later, because we need the internals of generator in order to we at least need a constructor, right? So I'll just declare that for now. Calls promise.initialSuspend. So this is how we control what we do when the coroutine is started. This says the typical promise types either return suspend always for ones which are lazily started, or suspend never, which are eagerly started. We want to control the starting of this coroutine ourselves, so we're going to return suspend always, which is in the coroutine header. So we'll include coroutine. While I remember, in here I'll have to say target compile options for generator test is C++ latest, so that we get our C++ 20 features. All right. So we need std suspend always initial suspend. And this is just like a tag type. It doesn't have any state. We just return this type to say that we're always going to suspend when the coroutine is started. Just exit right back to the caller. Okay. So we've done our initial suspend, and when we have a coroutine, we call return void for if we coroutine at the end or if we fall off. Returning is going to do nothing, right? Like our generator type, we're only concerned about yielding. So if we return, we just want to do nothing. So return void, is going to be a no up. Okay. Or calls promise.return value. We're not going to implement that because we're not going to be returning values. Destroys all variables that's handled by the compiler. Calls final suspend. Final suspend I don't understand as well. Like, I'm going to suspend always, but I don't know what the difference is between suspend always and suspend never for final suspend, because like you're exiting, so you're going to go back to the caller anyway. So I'm sure there's some difference where, some cases where it makes a difference. I don't really understand. If you do, please drop a note in chat. Like, why would you have suspend never on final suspend? I'm not sure myself. Okay, if coroutine ends with an uncaught exception, it catches and calls unhandled exception. I don't really want to handle exceptions, but I'm going to do it anyway. So if the coroutine ends with an uncaught exception, then we want to essentially store it in our promise object and then rethrow it if we need to. So I'll have a let's include exception. So I'm going to store an exception pointer in our generator promise type. Thanks to follow Jake. And if we call unhandled exception, then we want to store into exception the current exception, which is std current exception, I think. Is that right? Oops. Is IntelliSense going to tell me? It is current exception. Okay, so that's going to get the current exception which is running, and we're going to store a pointer to it in our own object. Cool. Presumably we're going to want to rethrow this later, so I'm going to make a function here to do that. Rethrow if exception. Then I'll check if we're storing an exception, and if we are, then we rethrow it, which is, yay, it did rethrow exception. It's almost like they thought about what would be the most sensible names and then used them. Oops. There we go. All right. So unhandled exception, we've done that. Calls final suspend, we've implemented all this. Destructor of the promise object. So I guess we don't need to do anything for that right now. All this is going to be handled for us. Cool. All right, heap allocation, we're not going to bother with any of that. Promise type. So this tells us how to get the promise type from our object using coroutine traits. I think for this you can straight up say, let's start implementing our generator type. Pretty sure if we say using promise type for generator, is generator promise. I think that should work fine. Yeah, it's defined to our promise type. So this will just get our promise type from our generator type, which is handy. Okay, so that's all fine. Co-await, we're not going to support co-await. We just care about yield, so I'm just going to skip all of this. And co-yield. So if you co-yield something, then that is equivalent to calling yield value on our promise type and then co-awaiting on the result. So this is where some of our magic is going to happen. So since our promise is being co-weighted on, then yeah, we can return suspend always to suspend back to the caller when we yield a value. So suspend always, it's called yield value, and this is just gonna pass us whatever we call that yield expression with. So in this case, we'll be passed whatever type T is. Now, since this coroutine frame is going to kick around for the whole time, we can straight up take a pointer to it. So I can just say we're going to take a T reference with T is a reference. I think I'm going to make a bunch of aliases up here. So our value type, I'm going to say is remove reference T. So this is just in case, because we could pass int as our generator type, or it could be int reference. So I just want to be explicit about that here. Our reference type is value type ref, and our pointer type is value type star. Thanks to follow, Michael. Okay, that should work, I think. Include type traits up here. Okay, so we're gonna take our reference type here and store pointer to it. So we can hold our pointer type. So this is our communication channel. This is, we have yielded something from inside our generator, and we're now going to store this in our promise object so that in here we can get the value. Typo in type def, reference type, ref, thank you, reference type. Someone says, don't you need : type? No, because I'm using remove reference _ T. It's the same thing. Cool, so yield value, I'm just going to store address of v in value. All right. last thing we have not implemented yet is get return object. I wonder if I can just say, go and create a definition. Yay, it does broadly the right thing. So I can stick this here. Okay, so getting the return object of our promise is going to create a generator. Now this is where we need to get a handle to our coroutine. So when we create the return object, we can get a handle to our coroutine using I can't remember what it's called, but it's a static member function on coroutine handle. So coroutine handle represents a handle to the coroutine, and this is it. We can get a coroutine handle from our promise object. So in here we can do generator, stood coroutine handle from promise, and then give that our promise object, which is this. Okay. I think this is right. Our coroutine handle needs to be templated on the promise type, which is generator promise. Okay, I think that will work. That will get us a coroutine handle from the promise, which we can then store in our generator. So go ahead and do that. Stood coroutine handle promise type. In fact, I'll go and alias that because we'll probably use it later. Handle type. Cool. Thanks for follow, Island Smith. And then we're going to store a handle type in here. And we need a constructor. Cool. That should work. All right, so this constructs our generator from our handle. So now we've got a bunch of our machinery in place already. So now what we need is things like this. We need a dot begin, we need a way to get an iterator from our generator, and we need that to drive our coroutine. So I'm going to create an iterator type. Can that generator constructor be explicit? Absolutely. Thank you. Yeah. Single argument constructors, make them explicit. Just save you a lot of pain. Okay, class generator iterator. This is going to be an iterator. Now with ranges, you don't necessarily need to compare a generator iterator to a generator iterator. You can just have a tag type, which we'll call sentinel, generator sentinel. So this is what you compare an iterator against to ask if you're complete or not. Okay, so our generator iterator and our generator sentinel is going to be our begin and end. So generator iterator for t begin, and generator sentinel, oh, detail. That's why it's not giving me. And I guess I need that here as well. And So this is just a tag type, so we can just go ahead and return that. Our template class and template type name are interchangeable. Yes, it's just down to your preference, really. I tend to use class just because it's shorter. Some people use type name if they think it's going to be more likely to be a built-in type. It's up to you. Okay, so begin. So when we call begin on generator, so we've created our generator, but the function hasn't started yet. It hasn't. We haven't run any of this code. So when we call begin to get our iterator, then we want to run up until we yield our first result. So we're gonna go. We have our handle, so we can call. Oh, I'm not getting any. Hey, LFO. So I can call handle.resume, which will resume our coroutine, and will either get us until we hit our co-yield, until we return, or if a exception is thrown. So we could go and we could check if our handle is done, then in case we did throw an exception, then we can rethrow. And we can get that through handle.promise.rethrow. Okay, so that will rethrow an exception if one did occur. But otherwise, we have resumed, we have rethrown if there was an error, and now we're going to return a generator iterator. And this will require our coroutine handle, because we're going to be using this iterator type to drive the rest of our coroutine. All right. So I think that's good. Can now implement our generator. So this is also going to have a promise type and a handle type. I'm just going to make this a struct. And it's going to store a handle. Just copy paste all this stuff. Okay, so the constructor is going to take handle type. And store the handle. So now when we call plus plus on this, which is what we do here, that is when we want to then continue the coroutine past the yield up until the next yield or return or throw. So that's going to do exactly the same thing as this begin. Operator plus plus. Just going to do this. I could deduplicate this, but yeah, it's fine. Can fix it later. Okay, so that will drive the coroutine forward, and then we need a way to get the value, which is going to be operator star. I'm going to go ahead and copy all these types over as well. You know, I'll get these from the promise type just in case I realize I've made a mistake somewhere and need to change it all. Do I need type name there? Not anymore, I think. I think we used to need it, but because promise type's dependent on template parameter. Cool. So operator star is going to return our reference type. and that is just going to straight up get our handle from the promise, promise from the handle, get the value, and because our value is a pointer, we're just going to dereference it. And this should give us back our value here. Cool. What else do I need? What else do I need? I think that might do for this test case. I need to get catch 2 working. I don't know why it's not finding the catch 2 header. Alright, what errors have I got? Yeah, I know, that's because I don't have my header. I found package, I added catch 2 as a link library to generator test. Anyone seeing what I'm missing? It's just, the header is just like catch.h, I thought. But it's not finding it for some reason. Can go ahead and rebuild because I never trust anything. Because I do have C++ version. I don't think that should make a difference here. Catch.htp. Yeah, I don't think it'll make a difference. I don't think I need target link libraries catch 2 for the generator because that's just the header only part. Because like this is building catch 2. It's finding it. It's only the tests which would need to link against catch 2. And it's not even linking against catch 2, it's just like including the header directories. CMake generation finished. Let's try now. Gimme. Why? I was literally trying this earlier and it worked fine. I could be awful and just like go and grab the header. Like I guess it's gonna be in here. It'll be in my VC package. I'll just go grab the header from online. Getting started. Can you catch 2? Yeah, it does usually work with VC package. It's usually absolutely fine. Wait. HPP. All right, let's try this. It's now doing a bunch more VC package stuff. You know, even for this example, like I don't even need to use catch 2. I could just stick this in main and see what happens. I wouldn't get the requires, but Alright, try now. Come on. Let's try and add. Yeah, don't do that. thing. Like, I can happily just, you know, write a bunch of coroutine nonsense, but getting dependencies and CMake to work, no chance. Don't know why this is taking so long. But wait, well, it's here, I can think of other things we would eventually need. Oh, there we go. Come on, build. What's the define I need here? Catch, define, main. Is that it? That's gonna take ages. Config main. Alright. Wait, final suspend must be non-throwing. Whee! Thank you, compiler error. Jeez. Okay, let's see what this does. Yield value must return a value. Suspend always is just a tag type again, so we can just default construct it, return. Wow, because I need the source file for catch. Okay, hopefully that's added it to my, yep. Is that a lot of double underscores in catch? In the CBP file? Not seeing any right here. Oh, it was in the error list. Oh, you're right. Yeah. Technically, undefined behavior. Yeah, C++ says don't use double underscores. They're all reserved for the implementation. Come on, build. Generating. Build. Oh, come on. This is like the absolute worst dependency management I've ever done. Like I said, I literally tried the same thing I was doing with VC package earlier, and it was working fine. Okay. Operator is ambiguous. Where's that? Oh, that's... I don't like that. It's good, so I'm not going to use catch 2. I don't want to deal with this. Just have main function and test out here. Okay, so we're just gonna write out what we get, and hopefully we get 0, 1, 2. Gonna remove this. Okay, so what we're hoping will happen is we create our generator, which is creating a generator object down here, which doesn't really do much. It captures a handle to our coroutine. because when we call first n, it's going to immediately suspend. Then when we call begin, it's going to run to co-yield. Then we're going to output 0. Then when we do plus plus it, it's going to go around the loop, increment, and we'll get 1 and then 2. So that succeeded. Let's test. So this is like the absolute bare bones of what? There we go. This is the absolute bare bones of a generator implementation, and then we can make it better. 0, 1, 2, yay. Okay, that worked. We did coroutines, we did generators. Now I want to be able to use this like a range. So I want to say something like, let's not do first n, let's just do TL generator, we'll do iota, start at some value, default 0, and just keep going, co-yield, T++. Okay, so that's an iota implementation. Now, what I want to be able to do is something like this for I in iota, say 42, and then pipe that to std ranges, views, not view base, take 10, say. Now what this should do is output 42 through 52. By piping iota 42 into view ranges take, we're saying this is an infinite generator. It's never going to stop because we're going round and round and round. And then ranges views take is going to take the first 10, which we're generating lazily. We're not doing this. We're not like storing any of this in memory. We're just saying this is going to be thank you, Leslie. This is going to be an infinite generator. We're going to take the first 10. Okay, so in order to do this, we're going to need to make our generator into a valid viewable range, which takes a fair bit of work, and also you do not get a lot of help from the compiler in the case of MSBC. GCC has really good compiler errors for concepts right now. We're still working on them for MSBC, but I'm going to make an attempt at it. If we hit any issues, I'm going to compile for GCC and use their compiler errors to guide me. Okay, so I know I need a viewable range. What's in a viewable range? So viewable range is something which is a range, and which is either a borrowed range or a view. We're not going to be a borrowed range, we're going to be a view. So now a range is something you can call begin and end on. We have our begin and end functions on our generator type, so that's good. But begin does require our iterators to be input or output iterators. Now what does this require? See what I mean? There's a lot of definitions here and a lot of nested concepts which become kind of ridiculous. So it requires that we can dereference. Okay, yeah, we can do that. Requires that we are weakly incrementable, which requires we are default initializable. We are not default initializable. So our generator iterator, these functions are nibloids. The begin and end functions on ranges are nibloids. If you don't know what a nibloid is, don't worry about it. It's like a function object which doesn't do, which stops ADL from happening and screwing with name lookup. So we need a default constructor so that we are default initializable. We need to be movable. I think we're probably movable already, but we do want to be movable. We do not want to be copyable, because like that means you would have multiple iterators holding onto this handle, which would be a nightmare. You know, you could drive one iterator forward and then that would drive the coroutine forward, so the other iterator would be affected. So these things are not copyable. So we could go ahead and disable that. And we need move assignment. Copy assignment will be deleted automatically, but we can make it explicit. I'll go leave a nice comment for myself as well. Non-copyable because coroutine handles point to a single resource, unique resource. Cool. Wouldn't the move constructor still leave both iterators pointing to the handle? Oh, that's a good point. I mean, like, we're not doing anything in the destructor, and you're not really supposed to do a whole lot with the other one. But yeah, we could go ahead and say handle is exchange RHS.handle and null pointer, just to null out the handle. Hey, claim. We got the basics working. We got creating our iterators and our ranges and driving the coroutine forward all working. We're now trying to make this a range so that we can pipe it into like views take and things like that. Okay, that should be fine. Do the same thing in the assignment operator. I like set exchange. It's one of those little features which just makes things nicer. And return this. All right. Not better? I think so. Okay. So requires we're default initializable, we're movable, we are both of those. Requires we have iter difference t. What should our difference type be? I honestly, pointer difference? Do we make it pointer difference? Is that reasonable? I'm gonna go for pointer difference unless someone tells me that that's wrong. Hoping some future version of C++ that's the exchange version of move can be auto-generated. Maybe, yeah. Code injection stuff could help with that. I think this is a reasonable difference type. See if it breaks. Okay, we have a difference type. Required that it's assigned integer, which pointer difference type is. Requires we can do pre-increment and post-increment. We did not implement post-increment. So we can go ahead and do that now, which is operator ++ int, and then we can just call operator ++ cast it to void. Done. think that's correct. Okay, so we should now be weakly incrementable, which was the requirement for input or output iterator. So that should mean that we have a valid range, okay? Now we need to make sure that we are a view. So we are already a range. This is for our generator type. Our generator type has to be movable. Again, we don't want generators to be copyable because it would be a mess. So I'm just going to go ahead and delete that. And for our move constructor, we want to do, I guess, the same thing as the generator iterator. In case we move, we're going to make sure that the other generator is nulled out. And then, you know, I'm just going to copy paste these because I think it's the same implementation. Oops, there we go. I think that's right. So we should now be movable. We need to be default constructible. So again, we want a generator which just leaves our handle as default constructed. Okay. And we need enable view. So this thing is a C++ ranges thing where you have to like explicitly opt into being a view. You won't be usable. Your type won't be usable as a view without you asking for it. Yes, this will be up on. I'll be putting this up on YouTube as soon as I get the captions all sorted. What was I just saying? Enable view. So in our namespace, no, in the global namespace, we can do specialize this template. TL generator for T is true. And this needs to be std ranges enable view. This should work. This is me opting into being a view. Nobody complains about generators being move only. I guess the thing is, what should happen if you copy this, right? Like you can't copy a coroutine handle. The handle is pointing to, you know, the coroutine has been created and has run to some point. You can't copy all of that state necessarily. Yeah, it could inherit from viewbase as well. Like maybe you can come up with a subset of generators which could be copyable, or some way to make the semantics work in some cases, but I don't know off the top of my head. Okay, so we're a range, we're movable, we are default initializable, we have enabled view. I think that should work. Share pointer. Yeah, but then your semantics are like it would work, but your semantics would be a mess. I think that should work. My experience is it never does whenever you're playing with ranges. Like this is already telling me that I've done something wrong. I'm gonna have to switch to GCC, I think. Oh, std exchange is not a member of std. It's a utility, right? RHS. Enable view, not in std ranges. Unrecognizable. Yeah. Just rebuild. Okay, so this is what I'm talking about, like binary pipe tail generator does not define this operator. So yeah, I think I'm gonna have to switch to GCC for debugging this. Like, I'm not seeing anything obvious. Like, I can do things like, you know, static assert that stood ranges, viewable range, TL generator, int. Yeah, just because the error is not clear enough, like GCC gives me a decent reason for why. Like, you see here, saying that the static assertion failed. So generator's not a viewable range, but why is it not a viewable range? Which of those 1,000 constraints did I implement incorrectly? I don't know. We will be working on this. Like, this is going to improve, but right now it's not there. So fortunately, I think this should be reasonably easy to get going. I can just target WSL. I have GCC 10 installed on WSL already. I might need to specify that. Oops. G++10. Switch here. And can see if this gives me a better idea. Yeah, GCC have done a really, really good job on, there we go, GCC 10. GCC have done a really good job on their concepts, error messages. So hopefully we will, just gonna remove this. We will catch up soon. Build. Oh, I need to switch up my CMake. If I'm in MSVC, then we'll do that. Otherwise, we want... I don't think the proper way of doing this for CMake works yet. Like, you're supposed to say, I want to use like CXX 17 standard or whatever it is, but I don't think it works for C++20 yet. At least for MSVC. And I think I need F coroutines as well. Has it been working for you? I'm going to check this. CXX standard. What's currently documented? Oh, so it does say 20, but what does it give to MSVC if you say 20? Does it supply C++ latest? Thanks to Fulham Info. Oop, cancelled. Let's see how this goes. There we go. This is giving me a better error. Cannot bind non-const L value reference up. So that was one issue, but I don't think that's the core of what was going wrong. I think there's some constraint I was missing on the... Here we go. Okay. Static assertion failed, viewable range. requirements, not satisfied. Okay, so this failed because of reasons. And then I can go back and I can supply minus F concepts diagnostics depth. Jeez, would help if I can spell. Equals, I'll say 3. So this essentially says, if there's an issue with concepts, go even deeper. Like, why was range's end not working? There's some other constraint further down which I'm not fulfilling properly. So supplying this flag just lets the things go a little bit deeper. Okay. So none of these were satisfied. Member end should be satisfied. Oh, I know. Our end function should be const. Still saying something's not working. No call to end. Let's go to the top, see where we are. Okay, so none of these are satisfied. Member end should be satisfied. Or at least I want it to be satisfied. Decay copy of end does not satisfy. The result of end is not a sentinel for the result of begin. Oh! Yes, we haven't specified comparison between our generator, iterator, and generator sentinel. That would do it. So friend operator equals generator, iterator, and sentinel. So this is when we want to say whether we are finished iterating or not, which is if we if our handle is null, or if we have a handle but the coroutine is completed. And then, oops, bool. Need the opposite. Cool. Do we need the other way around? I can't remember. Maybe. Just gonna make the depth a little bit deeper. Thanks to Paul Hooley. See if this gives me more information. Yeah, I think it should automatically work. Okay. I got so many template errors now. Alright, so invalid use of non-static data member. Because I need it dot handle. Still failing. Feel like I'm getting close though. Still this end function. Decay copy sentinel 4. Yeah, it's still the sentinel 4. What are the requirements for sentinel 4? T equals U. Boolean testable. Oh, I don't want to copy generator iterator. Yeah, it's supposed to be a friend function. Implementing comparison operators as friend functions is best because it means that they're symmetric in conversions. That looks better. Okay. Oh, I recognize this. Alright, so this is saying that I'm passing a constant counted iterator to this thing here. I know what this is because I was talking to Coroutines who implemented something like this earlier, and this is an LWG issue. This hasn't been solved in the standard yet. However, I know that MSVC does not have this issue, so I'm just gonna switch back. I'm pretty sure like if I make generator iterator copyable, then that error will go away. I don't really want to do that because it's super janky. Yeah, I'm doing some pretty crisp things here. Alright, let's see if MSVC compiles this now. Building. Whoa. This might work. So, if this works, if I run this, I should see the numbers 42 to 52 being printed out. Okay. Come on, come on, come on. Oh, yeah. It worked. Amazing. Okay. So, yeah, we've made it work. Our generator type is a valid range, so we can happily pipe it to views take. We could pipe it to transform. We could let's try that. We're gonna take the generate from 42 through 51. We're gonna take the first 10, and then we're going to transform it with we're gonna double all of them, turn I times 2. Yeah, now we can play around with this and try different types and things like that. Okay. So what issues are we having here? I is a symbol whose type contains auto, must have an initializer. What are you talking about? Is this a take view does not? If I got syntax error, or am I one bracket too few? Binary pipe does not find. So this is the kind of issue that you get when you're not satisfying a constraint, which is never fun. This is the right thing for transform, right? I think. I'm gonna switch back to GCC. I'll make this copyable so that it compiles. I think this will make that error go away that we had earlier. Yeah, there we go. Okay, so what's going on with transform? Argument deduction failed. Substitution failed. Required for iter value is invalid because I don't have iter value t. I got the wrong. No type named value type in counted iterator. Generator, iterator. I have no idea. Like, that should be something which is defined in counted iterator. Where is counted iterator implemented? Yeah, this is cool. This is like jumping around GCC code, which is inside my WSL instance. Yeah, counted iterator does not have a value type. Gonna look up. Like, this feels weird. I'm not sure if this is my problem or a standard library implementation problem. Yeah, I might leave that one. Like, we're playing with some, I don't know what the status of GCC's ranges implementation is. But yeah, we can try other things. The void generator, what does the void generator do? You yield just in order to stop execution like this. TL generator void. Like, std cout. Missing a closing brace. I don't know if coyield does. Is this the kind of thing you were thinking about for a void generator? Yeah, I think you need to have a where are we? Coroutines, coyield. Yeah, you need an expression or braced in out list. Can that be empty? Gonna look at the standard. Yeah, if regular void was a thing. Like, of course you could do this. This would be the same thing, right? I think that would work. Like, you could do clock, take the first 10, I is just going to be std monostate. Where is monostate? It's invariant, right? I don't want to include. There we go. Now we have regular void in C++. Yay, that was easy. Will this work? Will this print out TikTok 5 times? Move this here. Ooh, getting all sorts of stuff here. So maybe this is actually an issue in my implementation. Ambiguating new declaration. Okay. Oh, because I'm in the global namespace. Jeez. Tail clock. Yeah, we could probably do fizzbuzz. I do feel like there's something in here because I'm co-yielding an R value. Yeah, and I'm looking for a reference type. So how would you solve that? Is that when you use a const in here? Those are different errors. I have seen people having, usually like top level const doesn't make a difference, but for a generator, I think this is the case where you do want like a const type in here. No match for this. Operand types or clock T. Oh, there. TL. Oh, that worked. Did I get TikTok, 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 TikTok? Oh, it exited because it does that in Linux. Found on Windows. A yield star, which means you're in a generator function, which lets another generator function exit. Oh yeah, so that's, you can do that. You're talking about like recursive generators where you have a generator which yields to, oh, of course, I need to make this. Yeah. Yeah. Helps if I know where buttons are. Yeah, so the, yeah, basically when you have a generator which you essentially have a tree of generators, and at the top level you're always asking for a yield from whatever is currently executing, and they can chain together. You can implement that. If you look at CPP Coro, which is one library which implements a bunch of this stuff, they have a recursive generator where you do just like you said, you can co-yield an entry, or you can co-yield another generator, and these chain down. There's also an async generator. There is a paper which proposes a generator type for C++ 23. This one. And this is recursive. You can have a look at the implementation. It does make the implementation a fair bit more complex, and I would certainly not want to do that off the top of my head right now. Their implementation, you can have a look at it on Godbolt, but essentially, let's see. So symmetric transfer is the thing which makes this work. So they've got like keep track of the entire tree of coroutine handles, essentially, so that it transfers control around all of the coroutines which are currently running. So yeah, you can see like anything inside the symmetric transfer if def is having to do additional stuff to, you know, like when you do an await suspend, then you need to check out where we're going next and what coroutines are currently running and keep track of the tree. So it's a lot more work. Like this implementation is 1,000 lines of code, whereas my implementation is less than 200. Of course, theirs will be more thoroughly tested than mine as well. Like I did just write this in an hour and a half. What other things could we do here? Can check if this works now. We put a while true. I think since we're taking 10 of these, then it should print TikTok 5 times. Yeah, that looks right. Cool. So we don't have a generator void, but we can have a generator regular void. And if you're going to be co-yielding R values, then you need to make sure that your generator type is const, because otherwise you're not going to be it's not going to work. A generator of vectors of strings. All right, what's a case we could have there? Whoa. Okay, so what's this function going to do? We're yielding vectors of strings. So I'm just trying to think of like a test case which actually makes sense rather than, you know, just having a function split a sentence, return it bit by bit. I mean, we can do that for string, certainly. Split by lines, split by lines and white space. That would work. So if we take in a string view, and then we split by lines and white space. So every time we co-yield, we're going to return a vector which represents the line, and the stood strings inside the vector are the string that is that line split on white space. That should work. So we have our string view. We want to let's just create a vector. Like, you could do this with ranges. I've been writing this stuff for a couple of hours. My brain is fried, so I'm just gonna write this imperatively. So we're gonna accumulate into result. String handling in C++ is so bad. Let's just say we'll do this the super naive way and make it only work on ASCII and say I'm just gonna loop and accumulate a string. So I'm just gonna keep walking along the string view until I find a space and accumulate everything into split. Or I guess, what do we actually have in string view? I haven't looked at string view in way too long. So we can find, we could find the first space and then construct a string based on the position we get back. That could work. Take a character, string view dot find first. Oh no, find first of is that right? Yeah. Find first of space starting from 0. And then we can create a new string from our, I'll start off just with SB. What's this string constructor? We can give it a pointer and yes, the 400 constructors of string. This one, a pointer and a count. So this will at least work for the first call. But this isn't going to work either because we're just going to walk over new lines. My brain is so fried with coroutines and generators that I can't even do string handling. Alright, so we have our string view. We have our results. We're going to build up a single line. So while our, yeah, like I could pull in boost, but I don't really want to do that. Let's just take a pointer to the start of our vector, our string view, and while we are not new line, then and oh, whoops, while pause is not the end, and while we're not uline, then we're gonna keep going, and then we want to look for our first space. So I almost want to write a parser properly here. How do you all think that I should do this the best way? Because the idea is that at some point I want to be co-yielding my result string, and then in here I want to be taking a string like my input is that, and then saying split by, what do we call it? And then this should give us a line, and for auto, because our I is a vector, for each string in line. When I put the string and then comma, I'll have a trailing comma, but that's fine. So that's what our usage will look like, right? I put line. Ah. All right. So that's what we want to get out at the end. And we'll just, while we're not at the end, if our if what we're currently pointing at is is a space, then we want to res.push back a new string starting at start equals sv.begin. Our position is sv.begin. So we push back a new string from start to position, and then set start to pause. If we see a new line, then we want to co-yield our result, and then clear. Is that an algorithm which makes sense? Just keep going until the end. If we see a space, we're going to push back the substring, and otherwise, if we see a new line, we're going to yield our line back and clear it, and then also set start to pause. Let's try that, see what happens. Probably seg fault. Kind of co-yield did exchange res null pointer. I think for that it would I'd have to yield a const because it'd be return. Oh no, did exchange returns. Yes, did exchange does return by value, so we need like a constant vector here and stuff. What happened there? I just got like a billion lines. What's right at the top? Anything sensible? No. So that's obviously yielding. Oh, I need to increment pause at the end. Hey, cool. That worked. Mostly. Not quite, but almost. Got rid of the last word on every line. But other than that, it's like my algorithm's wrong, but the generator type is working fine. I could generate std vectors of std strings and share them back to the caller. It's pretty cool. I thought that would that would break something. I want to get this algorithm right. What was I missing? Oh, when I get a new line, I also want to push back the last thing before I clear. Cool. And, you know, I could deal with empty strings, but yeah, that works. I'm happy. Got about 10 more minutes that I planned on being on, so I can try any other stuff. You know, I'll go ahead and push this so that y'all can play around with it as well. So that should be at github.com/tartanllama/generator. That's the old one. Oh. Oh yeah, because I renamed the branch. Manage branches. Change the upstream branch. Push that. So that worked. There we go. I call this HPP. I don't like .h. But yeah, that's pretty cool. A couple of generators did random. I think that should just work fine. It would be something like TL generator of ints, and then I need to remember how all of the random generators work. So basically do copy, paste, not stdrand, go away. Yes, uniform int distributions, all that jazz. Yeah, fine. And yeah, TLRand is the way to go. Yeah, let's roll a bunch of d6s. Co-yield. How do you do this again? Distrib gen. Okay. So now if I for auto I in rand, pipe to std ranges, views take 10, That should give me 10 random d6. Do I need this? Distrib gen can't be called. What is this? I can never remember how to do a random seeding. It just never works. Can't convert from int to int ref because I'm yielding an R value. No global operator found. So I guess now I'm hitting problem of, this is maybe an actual issue, problem with yielding, with piping my const generator into views take. I think that's probably a bug. What does GCC think? It's probably something that I'm not taking into account when I have const references floating around. Alright, what's the difference? So we've got begin is invalid because our member begin is broken because T is of non-class type. Why are we trying to call dot begin on an int reference? There's definitely something going wrong here. So, trying to pipe my range. My range is int. My range should not be int. Why does it think my range is int? My range should be a generator of int. Oh, Jesus. Because it's picking up stidrand. There we go. I hate namespaces. Or rather, I hate global namespaces and also ADL. Let's try that. Yay! Random dice. Cool. So it wasn't a problem with const references, it was literally I was calling stidrand. So yeah, no, we have a random number generator where you can just take as many you want from it, and otherwise it will just keep going. Cool. I can't remember what I updated. Update the best commit messages in this stream. Alright, so you should all be able to go and, wherever I put it here, play around with this generator. At some point I might do the proper CMake stuff, create VC package ports and stuff, but it's about 4 o'clock now, so I think I'm gonna head off. But thanks so much for everyone who tuned in. I'm glad that we got this working. I think I'm gonna do another stream next week. Try and do this every week. next week I was thinking about playing around with WinUI 3 and C++ WinRT, because that has a bunch of coroutine stuff as well. Like you can, switch the thread you're running on during a function call, because you use coroutines to switch threads, so you can switch from like the UI thread to a background thread and then back. It's really cool. So I was thinking about playing around with that. If any of you have any things you would like me to cover in the future, then either just let me know here, or you can find me on Twitter @TartanLlama. But yeah, thanks so much for joining in, and I hope you have a good day. I'm gonna go and find some food to make, and might play some Apex Legends later this evening. Haven't played in a few days. It's my default way to unwind right now. But yeah, I will see you all around. Bye.